Right, so next algorithm is called Prim's algorithm. So last time we did Kruskal's algorithm, which is built up with the arcs. Prim's algorithm does the same thing. It finds the minimum spanning tree. But instead of, shouldn't talk and write at the same time. Instead of using the arcs, Prim's builds it up using the points instead. So P for Prim's, P for points. So the steps are here, but we'll talk through it in an example. So this is the same spanning tree that we did last time, and same network that we did last time, but we did Kruskal last time. This time we're going to do Prim. Usually the question will tell you which point to start at. So we're going to start at A and build this up as we go along. Okay. So you can start at any point in this network, but we're going to start at the point A. And we just build this up as we go along, adding on the shortest arc that we can. Okay. So I'm starting at point A. I'm just looking at the arcs that are connected up to A, which is A to D, which is 20, and A to B, which is 19. I add on the shortest out of those two. So I'm going to add on A to B first. Okay. And I'm going to, you've got space underneath, so I'm going to build this up as I go along. Got point A here. And I'm joining it up to point. Okay. It'll usually say list the arcs in the order which you add them to your tree, which is what I'm doing here. So I'm doing A, B first. And then I repeat the process. So now I look at all of the arcs which are joined up to both A and B. So I've got this 20 from A to D. I've got this one on already. And then anything that's connected to B. So I've got this 12 from A to B to D, and I've got this 13 from B to C. I add on the smallest of those, which is B to D. 12. I'll draw this underneath. Now I've added on A, B, and C. And then I repeat the process. Now look at everything that's connected up to A, B, and C. Well, I can't have A, D anymore because this would make a cycle, and I can't have a cycle in a minimum spanning tree, so I can ignore that. Connected up to B, I've got this 13. And then for D, I've got the 10 from D to F, the 12 from D to E, and the 15 from D to C. The smallest out of those options is D to F, which is 10. This is the next one that I add on to my spanning tree. Again, look at everything connected up to these. So I can ignore A to D. I could have B to C is 13, D to C is 15, D to E is 12, but the smallest one that I can have is F to E or E to F. Doesn't matter which way around you write it. Add on that 8. And we'll just need one more arc to join C up for this, and then we've got a minimum spanning tree once all the nodes are joined up. So look at everything, all of these now that are connected up. So I've got this 13 from B to C, 15, I've got the 12 and the 14. Now 12 is the shortest arc, but I can't add this on because it would make a cycle around D, F, E. So the next shortest is 13, which won't make a cycle, so I can add that one on, which is BC 13. And then that's my minimum spanning tree. All of my nodes are joined up in the shortest possible way. It asks for the weight of the minimum spanning tree, so you just add these together. Which is the same as what we did last time. And you can check back in your pack, but we've got exactly the same minimum spanning tree here, just using a different method. There's a table in your pack just outlining the differences between Prim and Kruskal's. Neither one is any better than the other one, really. It's just two different ways of doing the same thing. The big difference is kind of where you start and what you work on. So Prim starts at any point, any vertex, and you add on the points as you go along. Kruskal starts with the arcs and you add arcs as you go along. So that's the big difference between the two. Then Prims, as you do the minimum spanning tree, it's connected up as you go along. Whereas Kruskals, you just add in random arcs on and it all join up in the end. Really nice. So we're not going to do Prim's algorithm again, but we're doing it from a table this time. So the steps are in your pack, but again, I'm just going to talk you through an example. This is the information in the network in a distance matrix. So we did this at the end of the last pack, where you just put in the connections between each. So we can put their weights in and then dashes if they're not connected up. Okay, usually you'll get given this, so I think. And we're going to do Prim's algorithm on this matrix instead of on the graph. I think it's easier from the graph. But this, you have to be really careful with how you do this, how you label it all up, but everything has to be kind of exactly how they want it to be in a decision question, otherwise you will lose that. So what we're going to end up doing is we're going to end up crossing rows out and circling things and stuff like that. So if you want to grab a ruler, or if you don't care, then it is my fun. So once we've added a node onto our minimum spanning tree, we're going to cross out the row that it's in the network. So if we're going to start from vertex A, I'm going to cross out row A, and I'm going to label up column A with a 1 at the top. Okay, because this is the first node that I'm looking at. Okay.
We have to draw this table.
They could ask you to do it, but usually they give you it. So cross out the row that A is in and label up the column that A is in with a 1. Okay, so this is the first node that we're looking at. And basically what we're doing is looking down this column, you're looking at all the arcs that are connected up to A, and you're choosing the smallest one of those, which is what we did on the graph, but now it's in a matrix. So I'm going to circle I'm going to circle this AB here. This is the smallest one. And once you've chosen the smallest one, you then cross out the rest of the row that is in. Okay. So cross out the row that B is in, then label up column B with a 2 because we've chosen node B. And now we're looking at both points A and B. So this is all of the connections up to A and B that we can look at. Okay. Look for the smallest out of all of those. So both column A and B, not just column B. So the smallest out of those is A to E. So you circle that one. And then once you've circled that, you cross out row E, and then you label up column E with a 3, because that's the third node that you've added onto your arc. And you're building up the arc as the minimum spanning tree as we go along as well. And list the arcs as you go along underneath as well. Okay, so we added on A, B, so you can start drawing your minimum spanning tree, and you can make a list of the arcs that we're adding on. Okay. We've added on AE next. So we label up, cross out row E, label up the column E with a 3. And you look for the smallest out of all 3 of those columns that you've labeled up so far. So we could have the 7 in the bottom left. We've got 5, 8, 2, and 5. Choose the smallest of those, which is 2. Circle that. So we're adding on ED to our minimum spanning tree. Then you cross out the row that ED is, so that D is in, sorry, and you label up column D with a number 4. That's the 4th column, 4th node that we've added on to our minimum spanning tree. You're now looking at all 4 of these for the smallest value, which is, so you can have 7, 5, 8, 4, 8, 5. So the smallest out of those is this 4 from C to D. So circle that one, add it onto your diagram, add it onto your list. Then you cross out C, cross out row C, label up the column with a 5. And now you're looking down at all 5 of these. So just along this bottom row for the smallest out of those. The smallest out of those is E to F. So you're going to add that onto your diagram, you're going to add it onto your list, circle it, and then finally you can label up column F with a 6, and you could cross out row F. And you end this algorithm once you've labeled up all your columns and you've crossed out all of the rows. I think it's a little bit less intuitive than actually doing it from a graph, but it's just a process to learn. Yeah, so that's your minimum spanning tree. You could work out the weight of that by adding all that up. So I think you're 18. Okay, I'll do another one of these. It mentions in your pack that Prim's algorithm is of cubic order. There's a formula for the number of comparisons. You don't need to go away and learn that. It's just in there. It's because it's in the textbook. So I'll have a go at this one as well. So this one doesn't have the corresponding network for you. So obviously the other one did have the network, and if you've got the network, it's probably easier to just do the Prim's algorithm on the actual network. But this one is just in matrix form. So we're going to do Prim's algorithm on this matrix. If you're happy with what we've done, give it a go yourself. Otherwise, I'll walk through this slowly again. So we're starting from A. So the first step is to cross out row A and label up column A with a 1. That's the first node that we've got in our network. Then you look down column A for the smallest out of those. So the smallest out of those is A to E, which is your 130. So I'm going to circle that 130. I'm going to cross out the row that E is in, and I'm going to label up column E with a 2. And you can build your minimum spanning tree up as we go along. So they've just drawn a line from A to E and written down that we've added AE to our minimum spanning tree. You then need to look down both of these columns. So column 1 and column 2, what's the smallest out of those, which is the 82 at the bottom of column E. So add on EG. So add on EG to your minimum spanning tree, add on EG to your list of arcs that you've added. Circle it and cross out the row and label up column G with a number 3. You're then looking down all 3 of these, looking down A, E, and G for the smallest out of those. We've got 63 in column G. So that's the one that we're going to circle. We're going to cross out row F and label up F with a 4. And we're added on GF to our minimum spanning tree. So just added it on. And we've got a list there. Next one, look down all 4 of these columns for the smallest one. So the next one, I think, is 105, D to F. So circle that, cross out the row, add it onto your minimum spanning tree in your list, and label up column D with the number 5. Then look down all 5 of these columns for the smallest one, which is the 110 in column E. So circle that one, cross out the row. Add it onto your minimum spanning tree in your list. And label up column C with the number 6 because we just added that on. Finally, your smallest one after that is the 90 in column C. So you're adding on BC. Cross out the row, label up column B with a 7, and then add that onto your list and your minimum spanning tree. You get something like that. You can work out your total weight by adding all of these up, which you should get 500. So it also asks you for the number of comparisons. Just use the formula that's in the pack. So just it's a 7x7 matrix. So n is 7 nodes. So you just sub in n is 7, and there are 50 comparisons that we're putting.
Do you get given that?
I would think if you needed it, they would put it. Not on the formula sheet. I would have done it.